Hey guys, so in this video I want to go over lesson 3. Lesson 3 is properties of radicals and exponents. So a reminder, if we had 2 to the third, that is the same thing as 2 times 2 times 2. Remember also that the square root of 16 means the square root of 16 equals 2 times 2 times 2 times 2, which is the same thing as plus or minus 4. How you're getting the 4 2's is separating out that 16. 4 times 4, and then you have 2 times 2, 2 times 2. So there are your 4 2's that are under the square root. Since there are two groups of 2, we can multiply the numbers to get plus or minus 4. So because the index is 2, that is why we're grouping them by 2's, and they come out front, and we get 2 times 2, which is 4, and then we always do plus or minus coming from a square root or a radical sign. Another example, what if we had cube root of 8? So this you haven't seen yet, but we've already said it in words in our notes for lesson 1. Whatever our index is creating or telling you the size of your group that you're grouping together before you move out from under the radical sign. So in this case, 8 simplifies to 4 2 2 2. So there's 3 2's underneath the radical sign, and because we're looking for 3 roots, 1 2 3 of identical numbers, the 2 comes out front. It should be plus or minus. Since there are 3 groups of 2, we can pull a 2 out. It's just there in words. So let's look at going from exponent form to radical form. In the first case, we want to change a base raised to the x power to a square root. How do we do this? If we have a positive exponent, we're going to have a base, and it's going to be raised to a fraction, which in this case I've got 3/4. So here is your numerator, and here is your denominator. In this case, it is in exponent form, so we want to change it to radical form. How we're going to change this, we're going to have a radical sign. Our base is going to be inside. Our numerator is going to be what the base is raised to. And our index is going to be our denominator. So that is how we're going to switch back and forth. Now what if we did a negative exponent? So our negative exponents we're going to have a few different steps. So we're going to still have a base. We're still going to have a numerator and a denominator. But it's going to be negative. So So to change it into radical form, we're first going to deal with the negative exponent. To deal with the negative exponent, you're going to put it in the denominator. So now the 5/4 becomes positive, and you do these same steps you just did with a positive exponent. So 1 over, your denominator becomes your index, and your numerator becomes just your exponent. And that would be your radical form of this, or this expression. So let's do an example. For 7 to the 1/2. Your denominator is your index. Your base is underneath the radical sign, and your numerator is your exponent. Simplifying this would be square root of 7, because you would not need to write the 2 or the 1. Let's do another one. For your 4 to the 4/3, your denominator comes out front as the index, your base stays the same, and it is raised to your numerator. If you wanted to simplify this more, you have the cube root of 256, because 4 raised to the 4th. Now, what if you had a negative exponent? So, number 7. We have to get rid of the negative first. So we're going to do 1 over 5x raised to the 5 over 4th. So our denominator of our fraction of our exponent comes out front, taking the square, or the cube, or the radical sign, and then our base was 5x raised to our numerator of our exponent, which was 5. Another example, let's go down to 12. 12, we want to deal with that negative first, so we have 1 over x to the 1/2. We still have 1 over, but now we're going to take our denominator of our exponent, radical sign, our base, to our numerator power. Simplified, we have 1 over square root of x. Now, what if we wanted to go from radical to exponent form? So we want to change it from our radical sign to our base raised to the x power, or to some kind of power. So if we're dealing with positive, then we're going to take the radical sign. Whatever number is outside is going to be our denominator. Our base is going to be whatever is on the inside. And then our numerator is going to be whatever the base is raised to. So this is going to change into x raised to the 3 over 4th. So what if we're given a fraction? We're going to take this fraction, for example, 1 over 4th root of x raised to the 5th. Well, our index is going to be our denominator still. Our 5 is going to be our numerator. So we're going to change this by simplifying our denominator of our big fraction. So now we have x to the 5/4. Then we're going to deal with changing it to negative. So we want all of this denominator to be in the numerator. So we change the exponent to negative. And that would be our answer. So let's go back. If it's positive, we have number 1. Our understood exponent of 1 is underneath the radical. We have a base of 2 to the first, and then our 6 is coming from our index. So this would be our answer. For number 2, we have a index understood as 2. Our 3 is our exponent of our base. So we have 10 raised to the 3 over whatever our index was, which was 2. If we look at some of these fractions, right now we have 1 over, we'll simplify our denominator. We have 6x raised to the 4/3. This simplifies to 6x raised to the negative 4/3 to get rid of the big fraction. Let's do another one. In this case, we have a index of 2. We would have 1 over 3x raised to the 5/2, which simplifies to 3x raised to the negative 5/2 to get rid of the big fraction. Now, as a review of exponent properties, most of you knew it as I was going through them. When you're combining like terms, to add or subtract terms with exponents. So that would be combining like terms. Make sure you know that it is same base, same exponent. Now, if you are multiplying powers, to multiply powers with same base, multiply the coefficients. Keep the base the same, and add the exponents. When you're dividing bases or powers, you are going to divide the coefficients, keep the base the same, and subtract the exponents. For example, if you had b to the 4th over b to the 2nd, you would take your 4, subtract 2 from it. So you would have b to the 2nd. If it was flipped and you had b squared divided by b to the 4th, you would still have the first, or the numerator, subtract the denominator. So you would have b to the negative 2. Powers of a power. What do I mean by this? That means if we had b squared raised to the 2nd power. To simplify power of a power, keep the base the same and multiply the exponents. So in this case, you would have b to the 4th. if you have 0 exponents, like x to the 0th power, it always equals 1. Even if you have expression as extent as 3 x to the 4th times y times z to the 3rd. If all of it was raised to the 0th power, all of that would still equal 1. And then negative exponents. Any base raised to a negative exponent is equal to the reciprocal of the base and raised to a positive exponent. What do I mean by reciprocal? So if we take that b to the negative 2 that we had earlier, right now it looks like I can't take the reciprocal because it's not a fraction. But in reality it is. If I didn't want to change the value right now, but I wanted to make it look like a fraction, I could divide by 1 and it still be b to the negative 2. Well, the reciprocal of it would be 1 over b to the negative 2. But as soon as I take the reciprocal, the exponent becomes positive. That's just one of the rules. So today you have some practice problems to go through. You need to go through these and try them. If you have any questions, feel free to email me or ask questions.